Hi, my name is Shravanti. My team members are Anusha Konakala, Anusha Muppala, and Shravanti Somaraju. This video is regarding about Big Data Programming Lab assignment. So the first question here is, using a Hadoop map reduce algorithm, we have to find a Facebook common friends, and here we are using a scalar Apache Spark scalar programming. So this is the question asked for, and the other question is Spark graphics task. Using one of the following dataset, we have to perform a page rank, and we have to state the importance of using graphics on the chosen dataset. So let's go to the programming. So this is the Facebook friend find common friends find the programming here. So I have imported the Apache Spark and Apache Log4j for loggers and loggers, and this is the class name, and we have given a function, main function, and I have given a system.set property for utils. This is a Hadoop home directory, and we have a controlling log level here, and we have defined a Spark configuration and Spark context. So here we are, this is our map function here. Facebook friend FP friends mapper is our mapping function here. So this will in map function, it will read the input it will take every line as a string and splits the words every line into every line it will split. So we have given like words equals to line dot split, and val key equals to words, it will assign every word to a number like 0, and then it will page the words, it's a slices like words dot slice, it will make that 1 comma words dot size, and map friend. If I have given a condition here, if key is less than a friend, key comma friend, else a friend comma key. So it will pair the friends with, if suppose for example I have 504 in my input line, so it will take 5 as a key and 04 as a friends. So it will pair it with 50. Next time it will search for a 0 with 5, so they have a common friend as a 4, so it will show in the list. So for pair mapper like 4 for 40125 would return the following list, like 0 comma 4 they'll have a 0125, 1 comma 4 they have 0125, 2 4 like 0125. Then coming to the reduce function, it will groups by the key and intersects that key with the accumulator I have given to find the common friends. So this is our input data format, and this will be our output. In couple of minutes we will run and we'll see the output. Then in file we are reading our text file. So my input file is here. This is my input file. So for 0 is a user, so he has a common friends. 1 is a user, he has a common friends of 0 to 4. 2, he has a friends of 1 3 4. 3 is a user like 0. These the first column or like your key values here. Then in the results we are doing a flat map transformation here for a mapper, and we are reduced by key for a reducer, and we are filtering it. Then we are sorting the key, then the output we are saving it as a text file here. So I have already run my output. So this is the output for Facebook Finders. So 0 user and 1 user, they have a common friend as 4. If a friends of 0 comma 4 have a 1 comma 5 as a common friends, similarly 0 5 has a common friend as 4. Similarly 4 comma 5 has a common friend as a 0. So let's go to the other program like page rank. So here we have used a page rank for Nashville meetup dataset, which was given in the question. So similarly we have defined a main function with a system set property and Spark configuration. Then we have given a Spark session. here we have a controlling log level here. Here we are importing our data sets, which is I have taken a edges data set and groups data set from the Nashville meetup. So I'm passing this file path here. Then I'm printing the schema of the files of the datasets, like edges data.print schema, groups data.print schema. Then I'm creating I'm creating a temp file, temp data frame here, like I named it as edge and group. Then I am just performing a query on new data frames like group and edge. Then I'm renaming the columns and to find the distinct rows, distinct records in there. So I have created like a new name ID with the for the group existing in group ID. Similar to the edges, I have created a new name like source and destination for group 1 and group 2 in an edge dataset. To show our data frame, we have given like a graph frame of vertices dotted. Since we are performing a page rank by using a graphics, so we need to have like vertices and edges here. And then here I'm printing the number of vertices and number of edges count. Then here coming to the question, we are performing a page rank with tolerance and page rank with maximum iterations, page rank for a personalized vertex, like particular vertex we are trying, and we are also saving our output files to your file. So here we have taken a station page rank, which it calls to the graph dot page rank dot reset probability, like we have given a value like 0.1. This is a dumping value, so we can increase this value. Since if we increase this value, it will varies the page rank number also. So here we have taken the tolerance value 0.01. And we are showing a page rank for vertices dataset and edge dataset. Then performing with the max iterations for same probability, we are also taking a maximum iterations here, and with the same reset probability, we are also taking a particular vertex like ID here. So I have already run this file. So here in the output we can see the schema of the this is the schema for a group, this is schema for edge file. So here I am also displaying the records of vertices and records of edges. This is the records displaying the edge. So the total number of vertices we have 100 and total number of edges we have 500 in our dataset. Then this is the page rank for tolerance. This for a page rank for vertices and page rank for edge. So thank you.
Hi everyone, this is Anusha Konakalla. I'm going to discuss about the Lab 2 Task 3, which is basically to perform a word count on Twitter streaming data. Initially, we have added dependencies. Here is the Spark streaming Twitter dependency and Spark streaming dependency, Spark SQL to perform the other task, Spark machine library, and getting into code. Importing the required libraries, and here I am initializing the Spark configuration. Here it will check for the 4 parameters which are necessary for this. If they are not specified, it throws an error. Here I am controlling the log level, and it will take the 4 parameters that I will give, and this is to collect the specified tweets. We can mention here, and these are the system properties: customer key, customer secret, access token secret. These are the 4 parameters that has to be generated from a Twitter developer's account by creating a new application. one can generate these 4 parameters, and I have generated mine and used here, and I'm initializing the Spark configuration, and here I'm initializing the Spark context, streaming context. It is a main entry point for all streaming functionality. Here we have created a local streaming context with 2 execution threads and then a local batch interval of 2 seconds, and here it will take the data from an Twitter. Here Twitter utilities use Twitter4j to get the public stream of tweets using a Twitter streaming API, and I'm here printing the stream which I have collected here, and here I'm just splitting them with a space and filtering out the hashtags, and here I have performing the just map reduce, and I have used a reduce by key and window function here with a interval of 60 seconds, and here I'm printing the output. This is the stop and the wait termination. It will wait until it gets terminated, and if you see the output, this is the data that I have collected, and this is a stream that I have collected, and map reduce part, word count. This is the word under a specific count, and this is task 3 and getting into task 2. Here's the code that I have written. The thing is that to perform to construct one of the given data sets and to create a data frame and to perform 10 basic queries and 5 Spark RDD queries and Spark RDD data frame queries. Here we have considered the FIFA World Cup dataset, in which they have a World Cup dataset, World Cup players and World Cup matches dataset. Let's run this and see the output. Here I am initializing the Spark session, and I am loading the data from World Cup players and World Cup matches, and here I am printing the schemas. The program is running over here, and I am here creating the temporary views to perform basic queries and name them as a WC players and matches, and these are the basic queries. I have performed overall 13 queries, and for the RDDs I have loaded the data, and I am truncating the first part, which is an header part, and remaining the whole data is taking a variable and loading that variable, and I am performing the RDDs on that. Here I have used a filter option where first column equals 2006, and then printing out the required columns and the specific query and data frame, and I performed as well as in the Spark SQL. And the second one I have split it through comma, and when the second column equals to Italy, then I am printing the required columns whatever I want, and the same query I performed in data frame and Spark SQL. And here the third RDD query, where I have given a condition in which 7th column greater than 16, and the required columns I have specified here, and the same query in data frame and Spark SQL. And coming to fourth RDD, I have specified with the equality condition in which first column and fifth column are equal. Then I have specified the required columns that have to be printed, and the same query for data frame and as well as in Spark SQL. And here the fifth one, it prints the maximum matches player, through which I have given, for that I have given a condition where 8 column greater than 55. Same query in data frame as well as in Spark SQL, and this is the output. These are the schemas and the 13 queries that I have written. I have used ordered by, group by, max functions, count functions, and this is the RDD output, this is the data frame output, and this is the SQL output for the first one, and this is for the second one. in which I have given filter of winner equals to Italy. And this is for the third one, RDT, data frame and Spark SQL. And this is for the fourth one, for the country Brazil. The match is held in Brazil, and the fourth runner-up on a particular year, 2014. And this is for the last one, which I have specified the maximum players. That's it. Thank you.